Hi, this is Ms. Pellegrin, and today we're looking at Module 3, Lesson 3, Writing Products with Sums and Sums of Products. So today we are going to be looking at rectangular arrays and the distributive property. So we're going to be showing that distributive property with a rectangular array. Okay. Use the fact that the opposite of the number is the same as multiplying by a -1 to write in standard form. Okay. So you are in example 1. So this is example 1 on page 16. Okay, we're asked to draw a rectangular array for 3 times 3 plus 2. Okay, so we have the 3 that's on the outside. Okay, so we need to split this up into 3s. And then we have the 3 on the inside. So this is into 3s. And then plus 2. So that's representing the 2 that's on the inside. So we have 3 times 3, so there would be 9 within this section here. Just like you find area, 3 times 3 would be 9. And then in this area over here, we would have 3 times 2, which would give us 6. So together we have 9 plus 6, which gives me 15. So our answer on that one would have been 15. Okay, that was equal to 15, but we're currently just showing it to represent it. Okay, so we're going to do another one. Okay, so we still have the 3 on the outside. So we're going to have the 3 that we need to separate it into. And then x on the inside. We don't know how many x is, so we're just going to represent this as x. It could be smaller, bigger. The size is not of importance, it's just the representation. And then this would be 2, so we're going to need to split this in 2. Okay, so what's inside of that shaded region? So 3 times x is 3x, and then 3 times 2 is 6. So inside of this shaded region, there's 6. Inside of this shaded region, there is 3x. Okay, so the key terms for this lesson is the distributive property. I mentioned that word last lesson, and I know you've done the distributive property before. So our distributive property can be represented this way. So these are just letters representing numbers. So A times B, which is what we have here, plus A times C, which is what we have here. And it can be used with any number. Okay, so we are determining the area of each region using the distributive property. It is an exercise, so go ahead and determine what the region, what this would be, and what this number would be in the box. Okay, so 11 times 16, you should have gotten 176, and 11 times 5, and you should have gotten 55. So what we did here is we did 11 times 16, and we did 11 times 55. And so how would that be written? The 11 would be on the outside, and we would have 16 plus 5 on the inside. Okay, in example 2, draw a tape diagram to represent each expression. Okay, so in the first one we have x, and then we have plus y. So we have x here plus y here. We don't know how much each is worth, so it does not matter what size it is. And then we would have another that we're adding to that, x and y. Then we have another x plus y. Okay. The only thing that should stay the same is the size of the box that you made for x should be about the same for each, or should be technically the same, and same for the y. Okay, in your next one, we have 3 x's. So 1, 2, 3 x's. And then we have 3 y's. Labeling each helps you. You should label each one. Okay, and the next one we have 3x. So there are 3 x's. Did that terribly. And then there are plus 1, 2, 3 y's. Okay, and then finally we have 3 . And then this is going to be x. And this is going to be y. So in this box we have 3x, in this box we have 3y. So what we can see is that really we have the same in all 3. We have 3x's here, 3y's here. 3x's here, 3y's here. We have 1, 2, 3x's, 1, 2, 3y's. We have 1, 2, 3x's, 1, 2, 3y's. So each of these expressions, though they are shown in many different ways, they all equal the same thing. They're all equivalent to each other. They all have 3x's, whatever x may be. They all have 3y's, whatever y may be. So we might multiply. If we said x equals 3 and y equals 2. So we're doing 3 times 3 plus 3 times 2. 9 plus 6, and that's 15 if we were given some numbers. But a lot of times we're not. We're just given the letters and we want to condense it down. So this would be D and C would be your most condensed versions. This would be using the distributive property. This would be in standard form. These two are not in standard form. They are in expanded form. They have multiple x's and multiple y's. Okay, so we can conclude that they're all equivalent. How does 3x, 3 times x plus y equal 3x plus 3y? So there were 3 groups of x plus y, which is what we started out with in A, which is the same as multiplying 3 with the x and then with the y. How do you know the 3 representations of the expressions are equivalent? So the arithmetic, algebraic, and graphic representations are equivalent. Problem C is the standard form of the problems, B and D. And then problem A is equivalent to is the equivalent of problems B and C before the distributive property is applied. Okay. Under which conditions would the expression be most useful? So using it as one of these two, so that we can see that there are three groups of x and y, or that the sum is 3x and 3y. And so which model best represents the distributive property, which was that very last one that we showed with the array, D. Okay, in example 3, we're going to find an equivalent expression by modeling with a rectangular array and applying the distributive property. Okay, so we have on the outside 5. And we're not going to be putting the lines in between anymore. Then we're multiplying that times, and we can put it at the top or the bottom, 8x. So this is representing 8x, which we don't know how much that is. And then this is representing 3. So we're going to fix this a little bit. 8, we're going to assume if we're multiplying 8 times something, it's going to be bigger than 3. So that gives me a little more realistic of a picture. Okay. So 5 times 8 is 40, and then x, and then 5 times 3 is 15. Okay, so we can show our distributive property, 5 times 8x plus 3. So 5 times 8x is 40x, and 5 times 3 is plus 15. So in lesson 2, we talked about substituting a number to check to make sure that it would be correct. I like to use simple numbers, so we can say x is equal to 2. And make sure that both of these work when I say that x is equal to 2. So in the first one, we have 5 times 8x plus 3. We always rewrite the problem. Then 5 times 8 times, oops, I wanted to change that color so you can see it, times 2, plugging in for x, plus 3. So then 5, doing the parentheses first, so 8 times 2 is 16, plus 3. And then 5, 16 plus 3 is 19, and then 5 times 19 is 95. Okay. Does it work with what we said is equivalent? So 40x plus 15 is what we said was equivalent. So 40 times 2 plus 15. So 40 times 2 is 80, and 80 plus 15 is 95. Okay, so I found this way to be easier because I knew what 80 plus 15 was. I didn't know off the top of my head what 5 times 19 was. But it did work. Okay, so exercise 2, go ahead and you're going to have to draw an array. That's what we have been doing, the boxes for each expression, and then apply the distributive property to expand each expression. Substitute the given numerical values to demonstrate. So then you are also substituting to make sure that it is correct. It tells you what to substitute for. It says use x equals 5 on this one, and use c is equal to 1 on this one. So pause the video and go ahead and try that. Okay, so on the first one, you had an array. On the outside was 2. Here we had x. X we know is going to be 5, but normally we wouldn't, but I'm going to go ahead and make it bigger because the other number was 1. Obviously, that's not going to be too big. So on the inside, we had 2x. On the inside here, we had 2. And so 2 times x plus 1. Okay, so we're going to say 2 times. We're going to replace the x with what it tells us, which is 5. And then plus 1. And do what's in parentheses first. 5 plus 1 is 6. 2 times 6 is 12. What we have inside is 2x plus 2, because 2 times x and then 2 times 1. So if we plug in 2 times x, we said is going to be 5 plus 2. 2 times 5 is 10, and 10 plus 2 is 12. So yes, it did work. And it was correct. Okay, and then the next one, we have 10 on the outside, 2c plus 5. So 10 times 2 is 20c. 10 times 5 is 50. Substitution to check. So we'll start out with our original. We had 10 times 2c plus 5. So 10 times 2 times, we said 1 plus 5. So 10 times 2 times 1 is 2 plus 5. 10 times 5, 6, 7 is 70. And then inside of our boxes we had 20c plus 50. The distributive property, we showed that. 10 times 20, or 2c is 20c, and 10 times 5 is 50. So then we plug it in, 20 times c, and we said c is going to equal 1 plus 50. 20 times 1 is 20 plus 50. 20 plus 50 is 70. So it did work out. Okay, so you are continuing on with those exercises. Okay. It asks us to apply the distributive property only, and then substitute to make sure that we did it correctly. Okay, so 3 times 4f is 12f. 3 times minus 1 is minus 3. Okay, so then we are going to plug in and make sure that it works. 3, 4f minus 1. So 3 times 4 times f of 2 minus 1. 3 times 4 times 2 is 8 minus 1. 3 times 8 minus 1 is 7. 7 times 3 is 21. So then 12f minus 3. So 12 times f, we said, is 2 minus 3. 12 times 2 is 24 minus 3. 24 minus 3 is 21. So it does work. And then finally, 9 times a negative 3 is a negative 27r. And 9 times minus 11 is taking away 99. Okay, so does it work? 9 negative 3 times 10. I didn't write it out this time. Minus 11. So 9 times negative 30 minus 11. 9 times negative 30 plus a negative 11. It's 9 times negative 41. Okay, so then that's going to be a negative. 9 times 1 is 9. 9 times 4 is 36. So negative 369. Does it work here as well? Negative 27 times 10 minus 99. Negative 27 times 10 is a negative 270. Minus 99 is negative 270 plus a negative 99. So when we add that together, 0 plus 9 is 9. 9 plus 7 is 16. Carry my 1 is 3. So negative 369. So yes, it is correct. Okay. In example 4, we want to rewrite this expression in standard form using the distributive property. So we're seeing division here. How can we rewrite the expression so that distributive property can be used? So we have to change that division by dividing by 3 to multiplying by a third, multiplied by the reciprocal. So 6x plus 15 times 1/3. Okay, so we're distributing. And we can go backwards when we're distributing. So 6x times 1/3 plus 15 times 1/3. Okay, so 6x over 3 plus 15 over 3. 6 divided by 3 is 2x plus 15 divided by 3 is 5. So 2x plus 5 is our answer there. Okay. So in exercise 3, you're going to try it on your own. You're just rewriting each expression in standard form. Okay. So all of those divisions we're changing to multiplication and then using that distributive property. So go ahead and pause the video and try it on your own. Okay, so we have 2b plus 12 times 1/2. So then that's 2b times 1/2 plus 12 times 1/2. Distributing here, distributing here. So 2b times half is going to be 2b over 2. I'm going to come over here. 2b over 2 plus 12 over 2, which gives me b plus 6. 2 divided by 2 is 1. 12 divided by 2 is 6. Okay. 20r minus 8 times 1/4. So 20r times 1/4 minus 8 times 1/4. Again, I'm going to come up here. 20r over 4 minus, so we're used to writing plus, minus 8/4. So 20 divided by 4 is 5. R minus 8 divided by 4 is 2. And finally, C. And we can put it in the front as well, so we can say 1/7 times 49g minus 7 gives us 49g over 7 minus 7 over 7, which is 1. So 49g divided by 7, or 49 divided by 7 is 7 minus, or g, sorry, minus 7 over 7 is 1. So 7g minus 1. Okay, we're going to skip example 5 and exercise 4. We're going to look at example 6. A square fountain has an area with a side length of s feet. It is bordered by a single row of squares tiles as shown. Express the total number of tiles needed to determine in terms of s in 3 different ways. We're just going to look at it once. Okay, so we could look at it. This is s feet here. That amount is s feet. So this amount is s feet. Okay, and this is s feet. So what we can see is we have a 1 by 1 square here each time. So we could say that we have s plus s plus s plus s. And then there are 4 of the boxes. So plus 4. So that would be, there are 4 s's plus 4. Okay. We could also say, okay, well, we have, this is s, and then there's 1 piece left over. So we can say s plus 1. And how many times do we have that? We have that 1, 2, 3, 4 times. So we could write it 4 times. One, 2, 3. So that means we have a total of 4 s's plus 4. We could use the distributive property. We could say that because there are 2 on the outside, 2 times 4. Actually 4 would be on the outside. So if I took out 4, that's the common factor here. We have s plus 1. There are 4 here. We had 4 s plus 1s. We had 4 groups of that. Okay, which would still give us 4 times s is 4s, and 4 times 1 is 4s. So a bunch of different ways that we could look at that example. Okay, so some of the methods we used the distributive property, and we also showed it as rectangular arrays. So we were in what terms of a rectangular array, in terms of rectangular array and equivalent expressions, what does the product form represent? It represents the total area. So when we were doing an array, it was representing the total area. So we also got a little practice going back to look at area. We multiply length times width to find area. So that's what we were doing in those rectangular arrays. And that is it.